Oh, hello everyone. I think we are live and you are all on the Airbyte Community Call. And today we are going to talk about how lakeFS can work with S3 as an Airbyte destination. Let's just give it a couple of minutes for folks to join in and we'll get started. Mhm. I guess it's been a couple of minutes. We can get started. And hi again, I'm Vino, and I currently work as a developer advocate at lakeFS. And like I said, today we are going to talk about how lakeFS can work with S3 and act as a better Airbyte destination for you all to, in the data ingestion workflow. Let's get started. First, let's dive right in. When you use AWS S3 as an Airbyte destination to get your data from all these different sources, you can directly use S3, right? So, what are the challenges you would face? The first thing is when you write directly into an S3 bucket, there are no quality gates as such for during your ingestion process. You are writing into an S3 staging bucket, an S3 prod bucket, and there is replicas of your data that is sitting around in different S3 buckets that makes data governance difficult for you. And if you think about it, if you have GDPR and other PII regulations and concerns, now instead of applying that for one prod bucket, now you would have to apply it to your ingestion bucket and staging bucket and to your prod as well. And also copying the data all around is not an effective way to manage it, right? And when you're writing directly to production, there is always chances of corrupt data ruining your production pipeline. So, to avoid all of that, you would want some sort of isolation between your ingestion bucket and the production bucket, which is exactly what lakeFS could help you do. And when I talk about isolation, it's not just with, the staging and the production, but it is also in terms of producers and consumers. You have different data sources writing your data into S3, and you have different data consumers reading from S3 as well. You would want a layer of isolation between these two to avoid the data corruption or the data inconsistency issues. And to add to that, now there is also consistency issues across the data sets, right? If you have multiple questions, like multiple data sets that are coming in from these different sources, and sometimes when you want to, like when you have a data lake, which is an S3 bucket, for example, you have all these data sets that are working together to, create a data product for yourself, right? And in that case, you want to do the data versioning or all the quality checks and isolation needs to be created across data sets to ensure the consistency. Like, for example, you don't want to, create analysis on some products when the sales data for those products have not even been updated yet. Meaning you want the ingestion of all of these data sets to happen at the same time, or they don't. So the downstream analytics teams are provided with consistent data sets for the analysis. And these are the challenges one needs to address to have better quality data ingestion pipelines, and which is exactly what lakeFS helps you with. But before we get into how specifically lakeFS helps you address each of these challenges, let's just dive in and understand what is lakeFS, right? lakeFS is a data versioning tool. lakeFS offers Git-like versioning capabilities on top of your object stores. Say, for example, you're working with AWS S3 or Google Cloud Storage, or even S3 API compatible storage like MinIO or even HDFS, for example. So wherever your data may be, lakeFS can offer Git-like interfaces to manage your data just like how you manage code. You can create branches, you can do commits across the data, you can do merges back to multiple branches, and you can even revert if there is a problem and you need to revert back to a consistent state, right? And all of these functionalities are available as APIs, as CLI, and also in the lakeFS UI, right? And imagine in this example, as you can see, it's lakeFS sits on top of these object stores and sits as a metadata layer on top of these object stores to help versioning of these data objects. So currently, if you are using a host of applications, say Kafka, Spark, Airflow, Athena, Hadoop, whatever other query engines and applications you may be using to access the data, you can continue to use them just via lakeFS. So using it via lakeFS would give you the versioning capabilities and the atomic consistency capabilities as well. But by by changing the access pattern through lakeFS, what changes for you in your code, it it just does very, very minimal changes to your code. Like if you could look at the example here, if your application is reading from a specific S3 path, the updated S3 path would look like you would just add the branch name as one of the prefix in your S3 bucket, and that is it. So you could continue to access the data as how you were using it without much disruption. And as you can see, we have a lakectl branch create command. Like I mentioned before, when you have ingested data that's coming in, instead of writing it directly to production, you want to write it to an isolated ingest environment. And this isolated ingest environment is nothing but just a new branch of data that is branched off of production. So in a one line command, you will be able to create a staging environment for you to develop on. But when you create that staging environment, or when you're creating a new branch, lakeFS is not copying all of the data from the production to the staging branch. What it does is it only copies the pointers to the underlying storage objects and creates a new branch off of that. So essentially, it is a metadata only operation and it does not copy the underlying objects at all. So to understand this better, like for example, let's say you have your Amazon S3 bucket or AWS S3 bucket, right? And the first thing to start with, you would want to create a data repository, just like how we would create a Git repo, right? And on top of that, the data repository, you can create multiple branches, like say main branch corresponding to your production branch, or different versions of branches corresponding to your testing, or even ingestion branches, or several other experimental branches that you want. And if you have your data that is sitting across multiple tables, which is here, for example, just 1 and 2, this is how the versioning is done at the object level. So table 1 and table 2 have these different objects, and all of them are versioned in these two different branches. So all these data assets are under version control. Now, like I mentioned before, I wanted to reiterate how lakeFS creates these branches, because once you have all of your data that is sitting in your production, which is in the main branch, there are two ways one can create a branch, right? One, before promoting your data to your main branch or to your production, you want to have the incoming data, do all sorts of data quality tests and transformations. And only if the data is of good quality and if it passes through all the tests that you have already in place, you want to promote that data into production, right? To do that, what you want to do is branch off of the production data. You will have like a new branch that has access to all of the production data, but you're not actually affecting or risking the production data in any way. So, branch of production, write all the incoming ingest data into this branch, into the ingest branch, do all sorts of transformations, do your data quality checks, and then write back to the main. So when you do this branching off, it is only copying the pointers to the underlying objects, right? And once you start adding more files to the existing branch, it would of course create all those files, which means it is doing copy on write, you know, to add those files to the specific branch. And to understand the data ingestion use case better, what other features lakeFS offers for you? One is the ability to create a dirty ingest branch where you can do the transformations, quality checks, and then promote it to production. Another feature is the lakeFS hooks. The quality checks that we're talking about, they can be automated as part of the Git like workflow. If you've used Git, you would know the Git actions, which are more or less similar to what lakeFS hooks are in the functionality wise, right? So for all the operations that you want to do, let's say when you want to do a commit, or when you want to create a new branch, or when you want to merge it, you can have certain tests or hooks triggered, and only if the hook passes, then the specific action will be completed. Say in this case, for an effective data ingestion strategy, when you're using Airbyte to get the data from your different sources and write it into an S3 via lakeFS, you don't want to write directly into production. You want to write it to the dirty ingest branch, and then you have, let's say, a pre-merge hook. You can configure that, and only if the pre-merge quality checks have been successful, the data will get merged into production. This way, all the incremental data that is coming in from all these different sources would only be of, to ensure the quality of the incremental data. This would be really helpful. And also, at any point, suppose even after all these tests, if at any point the production data is corrupted, what would be a better way to deal with it? It would be to literally revert back, because like in Git, it offers, after you merge, you can also revert back to a specific commit and say, this is the commit at which the data is in a consistent state, and now the downstream consumers or analytics workloads are not affected. And like I just mentioned, like lakeFS hooks are more or less similar to the Git actions in terms of the functionality. So lakeFS hooks, it's nothing but a web server. It's, for example, you can have a Flask web server written that can handle the HTTP request for your lakeFS server. So there is a lakeFS server that does all the storage and the core operations like branching, merging, and committing, and reverting, and it takes care of the metadata or the layer on top of S3. But then the hooks is a different server. It's just a web server. It's going to serve the HTTP request that is being passed on to the lakeFS server every time there is a commit or a merge or any other operations that needs to trigger the hooks action. And the interesting part is, because hooks are flexible and it is separate from the lakeFS server, it also means that you can use any existing test suites to increase the data quality. Like, for example, most of us use Great Expectations, some of us use Soda.io. So you can use any of these as part of hooks to ensure the data quality as well. And how do you implement it is within these lakeFS branches, wherever your target branch is. For example, in your case, you would want to have lakeFS hooks enabled on the ingestion branch, meaning anytime the ingestion branch is being merged to your main branch, the hooks will be triggered. So you can select on what branches do you want these hooks to be run. And even on these branches, what kind of hooks need to be run. All of that is defined in an actions.yaml file, and you put the actions YAML into your lakeFS repository, and that is exactly how lakeFS knows what hooks it needs to trigger for what specific actions under what branches and so on. Here is an example of an actions YAML that I have, and what this hook does is it only checks for the Parquet files in production because some of us will have constraints like we only want Avro files in production in specific use cases or Parquet in other specific use cases and so on. This hook specifically checks for Parquet in production, and as you can see, the condition on which the hooks are triggered is a pre-merge, meaning before every merge action takes place, these hooks would be triggered and then the tests will be run. And on what branches is it going to be running? And on the main branch. And meaning only when you try to merge it back to the main, this is going to happen. It doesn't matter if you merge it to some other branch, it wouldn't affect. And as you can see, these are the properties of the hooks in the sense if you had a Flask server or any other web server configured, you can give the URL of the server, which would be mentioned in the properties as well. And the prefix is nothing but like something similar to an S3 prefix. Do you want the rules to be applicable to all of your bucket or only a specific prefix under the bucket? And these are the list of exhaustive hooks that are currently supported by lakeFS. So before for each of these events in lakeFS, you can have a corresponding hook configured and run every time this happens. And yeah, so you had an ingestion pipeline and you had used lakeFS hooks to ensure the data quality and merge only if the data is reliable. But despite all of that, if there is still ever a corrupt data in production, or if there is some issues that you need to troubleshoot, you can always revert back with lakeFS. It's lakectl revert command. Again, it's a one-line command. You revert back to a stable, consistent point of data so your downstream users and applications have a stable data to refer to while you are debugging or troubleshooting the issues in production. Like all the core operations, for example, branching, committing, merging, and reverting, we've seen in how lakeFS helps you do all four of these operations just like Git and enabling you to have an effective data ingestion pipeline. And now I've already gone over the atomic rollbacks in place. The idea is you don't have to do all of these manually. All of these can be part of your existing code. Let's say if you already have a DAG that is running every day that is going to populate your downstream, production tables or the data warehouses. lakeFS can be embedded, lakeFS can be integrated with any of those applications to run automatically. For example, if you already have Python, you can use the lakeFS Python client API to automatically do all of these steps. So there is less manual intervention, and it helps improve, I would say, the efficiency, and it streamlines the operation as well. And so when you have lakeFS sitting on top of your data lake, which is here our AWS S3, we would have effective, these three main problems taken care of. One is easily revert back from the corrupt data because of the time travel feature. And one more thing that you want to know about the time travel feature is it is consistent across multiple data sets. Meaning if you have more than one tables, and lakeFS helps you do the commit, branch, commit, revert, merge, all of that at multiple table level. So if you have 10 tables, hundreds of tables, the scale, at scale, you can do all these operations across multiple tables. And you can create these isolated branches on which you can run your tests, quality tests, or any sort of test, test or temporary transformations, or just spin up a sandbox environment just by branching out of production data to run any sort of experiments that you want. And hooks, of course, to ensure the quality. Now we've understood what lakeFS is, what it offers, everything. Let's just go on to understand how lakeFS can be configured to work with Airbyte as a destination instead of directly using S3, right? So in the config, let's just dive right in. And if you are an Airbyte user, of course you are. You're pretty familiar with the UI here. This is how the Airbyte cloud looks like. And let's just start with creating a connection. And I mean, creating a source, because that's how you set up a connection. And here, just for our example, I've just taken the movies data from the Google Sheets as a source, because the source can be anything, which is not our point of focus here. The point of focus today is about how our destination, which is S3, can have better workflows through lakeFS. So let's just have the movies data in our Google Sheets as our source, and we were able to configure this, with Google authorization and the batch sizes. We could just, set it to any number you want, and I've just set it to 200 just for the ease of it. And once you're done with the source config, let's move on to the destination, which is where AWS S3 comes in, right? So in the destination side of it, instead of using S3, we are going to route it through lakeFS. So what changes do you do in the config side of it? lakeFS talks to AWS S3 using an internal AWS S3 gateway. So lakeFS S3 gateway is the one which is responsible for talking to the storage of the object store underneath to make sense of all the operations that you want to do. So instead of credentials, now we would configure the S3A gateway as our destination, which you will understand as we go over these steps. So the destination type would be S3, like we know. And the S3 access key and ID would be the lakeFS access key and secret key ID. And the S3 bucket name would be the lakeFS repository name where you want your data to be written. And the bucket path would be the name of the branch under the repository, say main branch or dirty ingest branch or whatever it could be, or followed by any other path or the prefix that you want to add. And for the bucket region, since lakeFS is not like sitting across regions, you could just use US East 1 and it should run fine. And once you are done with this, let's just, for the normalization and for the output format, let's just stick to the standard ones, the CSV, and we don't want to flatten, we don't want to compress, because it's only a toy data set. We don't need all of these things unless you're running in production and you want to make use of all these features in your workflows. And the endpoint would be here, the HTTP endpoint of your S3 gateway, like I just talked about. So instead of an S3 endpoint, you would have an S3A endpoint. Or if you have lakeFS Playground, or if you have lakeFS running locally on your computer, you may want to give that HTTP endpoint followed by the port number as your endpoint in here. Once you have this all set up as your destination, you can go on to Airbyte allows you to set up the frequency, how often do you want your data to be synced and everything else. And once you do all of that, you would have the lakeFS UI, which I will take you through like right now to show you how the data from Airbyte would sit into a specific branch. Like we configured here, if you look at it, we configured the data to go to dirty ingest branch under the CSV. So we'll go see how the files look like and what we could do with lakeFS. Okay, so here is the lakeFS UI, as you can see, and it has multiple repositories, like example repository and another repository named my repo. And you can always create a new repository and just say, what is a new repo ID you want to create, and what is the default branch, and also the storage bucket, the S3 bucket on top of which you want to create a new repo. And let's say, for example, if we get into an example repo, you can see there is some data that's already here in the main branch. And as you can see, these are the uncommitted changes because we don't have any uncommitted changes yet. And you can see the list of commits that has been done on this branch. As you can see, I've been working on this earlier today and made a few commits, added data, and did a few operations. And you can see there is only one branch at the moment, And you can create a new branch anytime you want. Let's say, for example, ingest branch. And if you notice, after you created the branch, like I said, when you create a new branch, it is a zero copy operation, meaning it only copies the pointers underneath, not the actual physical objects, which is why the references or the reference commits are the same because nothing has changed. They're all pointing to the same references. So you created a new branch, so you can go under the new branch. It still has the same, everything is the same. And lakeFS offers you this option to create a tag as well. So specific, you can tag specific commits that you want to refer back to later. And let's say now we are in the ingest branch. Let's just upload some dummy object. Let's do the CSV probably. Now you can go to the compare and see that your ingest branch and main branch, they still have no changes because we have not committed those files yet. And when you go to the uncommitted changes, you can see the CSV file we just added. You can commit the file saying added the movies. And if you go and compare them now, you can see these changes. Uh-oh. Weren't there some changes? Okay, main has analytics, and ingest branch has analytics and CSV. Okay, so in the compare, when I do, okay, so I do see the changes, which is equivalent to a git diff, right? You can see all the difference in the files. And if these are the changes that you wanted to do, and if you're okay with the transformations and changes, you can continue to merge it. And if you don't want to merge it, there is also, consider this is like a sandbox environment you spun up just to run a couple of tests. In that sense, you don't need to merge it back to the production data because this was anyways a temporary environment. So you go back to your repository, you get your branches, and this is a temporary branch. We don't need it anymore. You could just delete and move on. And all of these operations we've like seen so far in the UI side of it, and you can run all these using one of the supported API clients. For example, just to like give you an idea of how it would look like, I have a Jupyter notebook and I have a Python lakeFS client installed. Meaning, if you are a Python developer who's using Python as part of your daily workflow for the data engineering pipeline, you could just have all these steps automated all the way from, let's just do the config quickly. And this is the lakeFS access and secret key ID and the lakeFS endpoint that we have running here. So let's just run that. And I also mentioned that we need to configure the S3A gateway so lakeFS can talk to the underneath object store, the underlying object store. So let us configure that as well. And once we have that, you can see that programmatically we can create a new branch. Let's just go ahead and do that. And then when we list the branches, you can see there is a main branch and an ingest branch. And you can go on to create another staging branch as well. And we can see there is a staging branch, there is a main branch, and then there is an ingest, like the ingestion branch. Now, let's say if either Airbyte or if it could be from any other multiple different applications or sources writing data to your ingest branch, because that is the situation we want to emulate, right? At data sources writing to your ingest branch, and then you are doing your tests writing it back to production. So let's just update the file, update the movies data, which is our data file, to one of the branches under the specific date partition. And once you have that, you can see the diff from that one. Because we added this file, you see the file is added, and you can also see the object. And for specific file formats, like for CSV, for example, you should be able to see even the contents of the diff file. Like if we go back and say in the example in the main branch, if you want to compare, I guess we have not committed it yet. Okay, so once you commit it, okay, what was I going to say was like okay, for smaller files, you may be able to see the actual diff as well, just like how you can see it in Git. But for the bigger, data objects, it doesn't make sense to do that. But once you can do all the data upload is done, now we want to do some sort of transformations. Let's just say, like, let's come back to it just a minute later, and we'll now read the data from the ingestion branch and then do all the processing, which is just exploring what the data is about. And then let's now try to process the data, which is happening in this step. I'm just trying to partition it by different columns and write it back to the staging area, meaning from the ingest, read the data, do some partitioning, write it to staging, right? Which is what I'm trying to do here. And once that is done, let's just commit the data to staging. And you can go see here, under the staging area, we will have movie types by CSVs, by different partitions, which we have it here. Okay. So the idea is once you have the data, you would want to write it to your production. Like staging is done, everything is fine. You can write it to the production. And it is merged into the production successfully. No conflicts, nothing happened. All is well for us. But the idea is instead of writing directly to CSV, we want to check for the data quality issues, right? If the initially, remember, we didn't want to upload CSV to production. We only wanted Parquet in production. So I have that hooks actions file, which is already there for me, which I showed you in the presentation. So let me upload this actions YAML into the lakeFS actions directory in my staging branch, because that's where I want to run my tests. And let me do that. So once I have my lakeFS actions and the actions YAML, the lakeFS server is going to now trigger the hook anytime there is a pre-merge or anytime there is a merge event, right? So let me try to merge again. Basically, let's try to push the CSV files back to the production again. But what would happen now is that the precondition failed because the pre-merge hook was aborted. Because the failed on the action Parquet only in production, Parquet format validated. You can see that by going back to the lakeFS UI, and under actions, you can see the pre-merge event has failed, and you can look at the Parquet only in production and look at the details of how it failed and everything else. So this is exactly how, instead of directly writing it to S3, by having the lakeFS layer sitting on top of S3, you have the data quality ensured in your ingestion pipeline. And I hope this was helpful. And if you have any questions, feel free to drop it in the chat. I'd be happy to talk more about lakeFS. And if you want to know more about lakeFS or how a specific connector, like the Airbyte to lakeFS connector works, or if you have any other questions at all, feel free to join us in our Slack community. We have all the fellow data engineers using lakeFS, talking about different data architectures and how they're using lakeFS in their different projects and so on. And this is just a small list of companies that we thought you all should know who's using lakeFS. And that's it. That's all I had for today. Thank you, everyone.